Hello, in this lecture we will answer on two questions. In the first question, we'll find out the side length of square ABCD, and in the second question, we'll find out the length of line segment AD that is equal to x. So we'll start with the first question. In the drawing, we have square ABCD. We know that the short line segment DE equals to 1 unit, and the radius of this circle is equal to 2 units. Okay, so here, we'll define the center of this circle as point O. We'll define the point of tendency of tangent AD with this circle as point M. We'll join together points O and M by a straight line. O is the center of the circle, M is a point on the circle itself. This is exactly the definition of a radius, so MO is the radius of the circle. We define the radius of the circle as R, and we know it is given in the question that R equals to 2 units. So here we have the radius OM of this circle. It is drawn to the point of tendency. That is to say, it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AD will be perpendicular to the radius MO. So AD is perpendicular to MO, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we will define the point of tendency of tangent AB with this circle as point L. We will join together points O and L by a straight line. Here, line segment O1 is the radius of this circle because of the fact that it starts from the center of the circle and ends at point L, that is a point on the circle itself. So O1 equals to R, that is equal to 2 units. So here we have the radius OL. It is drawn to the point of tendency, that is to say, it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. And it is given us the question that ABCD is a square, and we know that all the angles inside the square are right angles, that is to say, angle DAB is a right angle that is equal to 90 degrees. So actually, in quadrilateral OMAL, we have 1, 2, 3 right angles. Okay, so write it down. In quadrilateral MOAL, we have 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle MOL. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we have the equation that the sum of three angles, that is 270 degrees, plus the size of the fourth angle, that is angle MOL. In total, they must be equal to 360 degrees. Here we'll subtract 270 degrees from this equation, and we'll get that the missing angle, angle MON, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So angle MOL is a right angle, it is equal to 90 degrees. Here, this angle is a right angle. So actually, in this quadrilateral MOL, we have four right angles. Any quadrilateral that has four right angles must be at least a rectangle. So we will relate to quadrilateral MOAL as a rectangle because it has four right angles. So quadrilateral MOAL is a rectangle. Okay. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle MOAL, we know that MO equals to AL. MO equals to AL in rectangle MOAL. But we have already found out that MO equals to 2 units. It is the radius of the circle. So we can write here that MO equals to 2. And from this equation, 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. Okay, AL equals to 2 units. So we can write here that AL equals to 2 units. Okay. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will get that MA equals to OL. MA equals to OL, rectangle MOAL, but here OL equals to 2 units. According to what we have already found out, OL equals to 2 units. And from this equation, MA equals to OL equals to 2, we will derive that MA is also equals to 2 units. MA equals to 2 units. Here, MA equals to 2 units. So all the sides of quadrilateral MOAL are equal to each other, they are all equal to 2 units. Therefore, quadrilateral MOAL is not a rectangle, but it is a square. Okay? In the next step, I will present to you the second rule, that is actually rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So, if we focus at the common external point, point E, this common external point, point E, we have two tangents to this circle. The first tangent is tangent EM. Here we will define the point of tendency of line segment EB with this circle as point Z. So the second tangent from point E to this circle is EZ. And according to rule number 2, the lengths of those two tangents must be equal to each other. So EM equals to EZ according to rule number 2. So what is the length of line segment EM? From the drawing, it is very easy to see that the length of line segment EM or tangent EM is equal to dA, that is the side length of the square, minus DE minus MA. Again, dA minus DE minus MA equals to EM. Here, EM equals to dA minus DE minus MA. In the next step, we will define the side length of square ABCD as X. So here, dA equals to DC equals to CB equals to AB, and according to our definition, the length of the side length of the square is equal to X. So here we'll get that dA equals to X, so EM equals to dA, that is equal to X according to our definition, minus DE equals to 1 unit according to what is given us in the question, so it is minus 1, minus MA equals to 2 units according to what we have already found out. So in conclusion, we get that EM equals to X minus 1 minus 2, X minus 1 minus 2 equals to X minus 3. So EM equals to X minus 3. You can write here that EM equals to X minus 3. So actually, according to rule number 2, we found out that EM equals to EZ, and we just right now found out that EM equals to X minus 3. So we can write down that EM equals to X minus 3, and from this equation X minus 3 equals to EM equals to EZ, we will derive that EZ is also equals to X minus 3. Okay, EZ equals to X minus 3. So we can write here that EZ equals to X minus 3. In the next step, we will focus on the common external point, point B. This point, in the common external point, point B, we have two tangents to this circle. The first tangent is tangent BL. The first tangent is tangent BL. And the second tangent is tangent BZ. And according to rule number 2, the lengths of those two tangents must be equal to each other. So actually, we can write down here that BL equals to BZ according to rule number 2. What is the length of BL? For the drawing, it is very easy to see that BL equals to AB minus AL. So here BL equals to AB minus AL. So actually BL equals to AB according to our definition. Here AB is the side length of square ABCD, and according to our definition it is equal to x. Okay, so BL equals to x. So we substitute here again, I'll repeat again, BL equals to AB minus AL. Okay, and according to our definition, AB equals to x, here AB equals to x, this is the side length of the square that is equal to x according to our definition, so we substitute AB by x minus AL. We have already found out that here AL equals to 2 units. We substitute AL by 2 units, and in conclusion we found out that BL equals to x minus 2. Okay, BL equals to x minus 2. So actually, according to rule number 2, BL equals to BZ, yes? BL equals to BZ according to rule number 2. And according to what we have already just like now found out, BL equals to x minus 2. And right here that BL equals to x minus 2. And from this equation x minus 2 equals to BL equals to BZ, we will derive that BZ is also equals to x minus 2. BZ equals to x minus 2. So BZ equals to x minus 2. And what is the length of line segment AE? Here, the length of AE. AE, from the drawing it is very easy to see that AE equals to, or EA equals to DA minus DE. DA minus DE equals to EA. So EA equals to DA, that is x according to our definition. It is the side length of the square that is x, minus DE that is equal to 1 according to what is given in the question. So in conclusion, we found out that EA equals to x minus 1. So in the next step, we will implement the Pythagoras theorem on the right triangle EAB. So I'll copy the right triangle EAB in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle EAB. So actually we have already found out that EA equals to x minus 1 we have already found out that AB equals to x, and what is the length of the hypotenuse EB? The hypotenuse EB is very easy to see from the drawing that EB equals to x minus 3 plus x minus 2. X minus 3 plus x minus 2. So EB equals to x minus 3 plus x minus 2. X plus x is 2x. And minus 3 plus minus 2 is minus 5. So in conclusion, we actually found out that EB equals to 2x minus 5. Now we will implement the Pythagoras theorem on this right triangle, triangle EAB. So in triangle EAB, by PT is the abbreviation for Pythagoras theorem, we get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is EB, therefore the square of the hypotenuse is EB squared, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to EA squared plus AB squared. Okay? So here we substitute EB by 2x minus 5. Therefore EB squared will be equal to 2x minus 5 squared. EA equals to x. EA equals to x minus 1, of course. EA equals to x minus 1. So EA squared will be equal to x minus 1 squared. Plus AB squared. AB equals to x, so AB squared is x squared. So here we will open the brackets on both sides of equation number 1 according to the algebraic identity that A plus B squared equals to A squared plus B squared minus 2AB. Okay, and we get that according to equation number 1, two x minus 5 squared equals to 2x squared. 2x squared is 4x squared plus 5 squared, that is actually 25, minus 2 times 2x is minus 4x, and minus 4x times 5 is minus 20x. Okay, and it is equal to x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, it is 1, minus 2x plus x squared. So in conclusion, we found out after we opened the brackets on both sides of equation number 1, we got this equation, and here x squared plus x squared is 2x squared. So I'll write it down. So in this side of equation number 1 we have 2x squared minus 2x plus 1. In this side of equation number 1 we have 4x squared minus 20x plus 25. So here we subtract 2x squared from this equation, equation number 1. So here 2x squared will get cancelled. 4x squared minus 2x squared is 2x squared. Here we have minus 20x, and in the other side of the equation we have minus 2x, so we will add 2x to this equation, equation number 1. So 2x minus 2x is 0, and minus 20x plus 2x is minus 18x. And here we have 25, and the other side we have 1, so we subtract 1 from this equation, equation number 1. So 1 minus 1 is 0, 25 minus 1 is 24. That is equal to 0. Here we divide this equation, equation number 1 by 2, and we will get that according to equation number 1, x squared over 2 is x squared, minus 18 squared over 2 is minus 9 squared. Here 25 minus 1 is 24, so 24 over 2 is 12, plus 12. That is equal to 0 over 2 is 0. So here we got the quadratic equation that x squared minus 9x plus 12 equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. The variable that we are looking for in this quadratic equation is x, and the general formula for solving out for finding out the variable that we are looking for, that is x, is that x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So we'll put the data inside this formula in order to find out the value of the values of x. So according to this formula, we get that x equals to minus b, b equals to minus 9 in our specific quadratic equation. So minus b is minus 9, that is plus 9, plus minus square root of b squared. B equals to 9, so b squared is 9 squared, that is 81, minus 4 times a is 1, times c is 12, over 2a. A is 1, so 2 times 1 is 2. So actually found out that x equals to 9 plus minus square root of 81 minus 4 times 12 is minus 48 over 2. So here we actually found out that x equals to 9 plus minus 81 minus 48 is 33, so inside out we left only with 33 over 2. And here we have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. Actually, 9 minus square root of 33 over 2, it is equal to 1.69. So according to the first solution, we found out that x equals to 1.69. So here in the drawing, according to the first solution, AB that is equal to x, that is one side length of square ABCD, x equals to 1.63. But here you can see from the drawing that AB is greater than AL. AB is greater than AL, and AL equals to 2. So AB that is greater than AL must be greater than 2. So from the drawing we can see obviously that x must be greater than 2 units. But according to the solution that x equals to 1.62, it is less than 2, and x must be greater than 2, so this solution is the incorrect solution. We will cancel the solution, and we left only with the second solution, that x equals to 9 plus square root of 33 over 2, that is about 7.37 units. So finished with the first question. Here we actually found out that x, that is the length of one side of square ABCD, it is equal to either 9 plus square root of 33 over 2, or in terms of numbers, x, that is one side of square ABCD, it is equal to 7.37 units. Okay? We finished with the first question. In the next step, I will present to you the second question. And we will solve the second question in two different methods. So here in the drawing we have triangle ABC, and triangle ABC, side AB equals to A units, side AC equals to 2A units, line segment BD equals to 2 units, and we know that angle BAD equals to 60 degrees, angle DAC equals to 60 degrees, again side BD equals to 2 units, and we want to find out that the length of line segment AD that is equal to x. Okay? You can see here that AD divides angle BAC that is equal to 120 degrees into two halves. Each half equals to 60 degrees. Therefore, we use with angle Basserto theorem, we use the angle Basserto theorem in order to find out the value of line segment DC. So what is the angle Basserto theorem? The angle Basserto theorem is true in any triangle. So actually, if we have triangle ABC, that could be any triangle. This is triangle ABC. And we have in triangle ABC the angle Basserto AD line segment AD is angle Basserto because of the fact that it divides angle BAC into two halves. Each half equals to theta. So AD is the angle Basserto. This is actually the angle Basserto theorem. So if we have triangle ABC that could be any triangle, and we have also the angle bisector AD, then according to angle bisector theorem, the following equation is true, that AB over AC equals to BD over DC. Okay, in any triangle ABC, if we have the angle bisector AD, then AB over AC equals to BD over DC. If we can implement the angle bisector theorem in triangle ABC, why? Because triangle ABC has the angle bisector AD. AD bisects angle BAC to two halves. Each half equals to 60 degrees. So we will implement the angle bisector theorem in triangle ABC. In triangle ABC, AD is the angle bisector. Therefore, according to the angle bisector theorem, we will get that AB over AC equals to BD over DC. I'll repeat again. In triangle ABC, we have the angle bisector AD, therefore AB over AC equals to BD over DC. Okay. So actually AB equals to A, so we substitute AB by A. AC equals to 2A, we substitute AC by 2A. And it is equal to BD. BD equals to 2 units according to what is given as the question. Over DC, the missing 9 segments. So we leave it as it is. So in conclusion, we found out that according to equation number 1, and according to the angle bisector theorem that we implemented on triangle ABC, here A over 2A equals to 2 over DC. A over A is 1, so A will get cancelled. So this side of the equation, we left only with 1/2. 1/2 equals to 2 over DC. Here we'll cross multiply this equation number 1, and we get that according to equation number 1, DC equals to 2 times 2, that is to say, DC equals to 4 units. DC equals to 4 units. So you can write here that DC equals to 4 units. In the next step, I will present to you a new law, what is the law of sines. The law of sines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. We note that the length of side BC equals to 3 units, the length of side AB, the length of side BC equals to A units, the length of side AB equals to C units, and the length of side AC equals to B units. So that is the law of sines. Then, according to the law of sines, we will get that A over sinus A so actually this angle equals to A, the size of this angle BAC is A with non theta, and B over sinus B equals to B over sinus B. That is equal to C over sinus C. Capital A, capital B, and capital C are the sizes of angles BAC, ABC, and BCA correspondingly. Okay, so in any triangle, if we have triangle ABC, that will be any triangle, then A over sinus A equals to B over sinus B equals to C over sinus C. So we can implement the law of sines in triangle ABD. This is triangle ABD. So according to the law of sines, if we focus on triangle ABD, we will get that 2 over sinus 60 degrees equals to A over sinus theta actually the law of sines is related to the second method, so we'll not use the law of sines here, but here we use rule number 3. So here we actually need to do the construction. We will extend line segment CA by a straight line. So we extended line segment CA by a straight line, and from point B we will draw perpendicular on the extended line segment AC. So this angle equals to 90 degrees according to our construction. we will define the touching point of the extended line segment CA and the perpendicular from point B is E. So here we extended the straight line, the side AC by straight line. AC is the side of a triangle. Triangle ABC is absolutely a straight line, and when we extended the straight line AC by a straight line, the result must be a straight line, because when you extend a straight line by straight line, the result must be a straight line. So we actually created the line segment CE by extending the straight line CA by straight line. Therefore CE is a straight line. Okay, CE is a straight line. So C is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so if we focus on the lower side of the straight line CE here at point A, then the sum of the angles here must be equal to 180 degrees. So which angles we have in the lower side of the straight line CE at point A? We have here 60 degrees, plus 60 degrees, plus angle, this angle that is actually angle EAB, in total the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, here 60 degrees plus 60 degrees is 120 degrees, so 120 degrees plus angle EAB must be equal to 180 degrees. We will subtract 120 degrees from this equation, and we get that the missing angle, angle EAB, equals to 60 degrees. Okay, this angle, angle EAB, equals to 60 degrees. In the next step, we'll focus on triangle EAB, on the green right triangle, triangle EAB. In the green right triangle, triangle EAB, we know that cosine 60 degrees, this angle equals to 60 degrees. Cosine 60 degrees equals to EA over BA. EA over BA EA, so it is EA over BA, and BA equals to A according to what is given us the question, so we substitute BA by A, and we have cosine 60 degrees equals to EA over A. Cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, so 1/2 equals to EA over A. Here we'll multiply this equation by A, and we'll get that EA equals to A over 2. EA equals to A over 2, or EA equals to half A. One half A, here EA equals to A over 2. We will continue to focus on the green right triangle, triangle EAB. On the green right triangle, triangle EAB, we know that sinus 60 degrees equals to EB over BA. EB over BA in the right triangle EAB, sinus 60 degrees equals to EB over BA. BA equals to A, so we substitute BA by A. So sinus 60 degrees equals to EB over A. We know that sinus 60 degrees equals to square root of 3 over 2. So we substitute sinus 60 degrees by square root of 3 over 2, and we get that square root of 3 over 2 equals to EB over A. Here we multiply this equation by A, and we get that EB equals to A times square root of 3 over 2. Okay, we found out that EB equals to A times square root of 3 over 2. And EB equals to A times square root of 3 over 2 units. In the next step, we'll focus on the right on the right big triangle, triangle EBC, and we'll implement the Pythagoras theorem on the big right triangle, triangle EBC. So we'll copy the big right triangle EBC and we'll implement the Pythagoras theorem on this triangle. So we already found out that EB equals to square root of 3 over 2 times A. EC, what is the length of EC? EC equals to 2A plus A over 2. That is to say it is equal to 2.5A. And 2.5A is 5 over 2A. And the hypotenuse BC equals to 2 plus 4, that is 6. Now we can implement the Pythagoras theorem on the right triangle, triangle EBC. By PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, therefore the square of the hypotenuse is BC squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to EB squared plus EC squared. So according to equation number 2, BC equals to 6, so BC squared is 6 squared, that is 36, and it is equal to EB squared. EB equals to square root of 3 over 2 times A squared, and EC equals to 5 over 2 times A squared. We will open the brackets on this side of equation number 1 and we get equation number 2. So according to equation number 2, 36 equals to 3 over 2 square root of 3 over 2 squared is 3 quarters times A squared plus 5 over 2 squared is 5 squared, that is 25, over 2 squared, that is 4, times A squared. So according to equation number 2, we get that 36 equals to 3 quarters plus 25 quarters is 28 quarters times A squared. 28 over 4 is 7. So we get that according to equation number 2, 36 equals to 7A squared. Here we divide this equation number 2 by 7. And we get that according to equation number 2, A squared equals to 36 over 7. Here we take a root out of this equation number 2, and we get that A equals to square root of 36, that is 6, over square root of 7. So in conclusion, we found out that A equals to 6 over square root of 7. In the next step, I will present to you a new rule. This is actually rule number 3, that is related to the angle bisector in a triangle. Okay, so if we have triangle ABC, that will be any triangle So this is actually rule number 3. Actually it is the second rule that is related to angle bisector. So if we have triangle ABC, this is triangle ABC, and we have the angle bisector AD, triangle ABC. AD is angle bisector. Because of the fact that it bisects or divides angle BAC into two halves. Each half equals to theta. So AD is the angle bisector. According to rule number 3, we get that AD squared equals to AB times AC minus BD times DC. So in any triangle ABC could be any triangle. If we have angle bisector in the triangle, then we can implement rule number 3. We have here this triangle, the angle bisector AD, therefore we can implement rule number 3 here. According to rule number 3, AD squared, that is the angle bisector squared, equals to AB times AC minus BD times DC. So actually we can implement rule number 3 in triangle ABC. Why? Because triangle ABC here has the angle bisector AD. So I copy the triangle ABC in the page, and in this page, and we'll implement the angle rule number 3 on triangle ABC. So this is triangle ABC, the copy from the original drawing. AD is the angle bisector. It is not accurate because DC should be twice as long as BD, but consider, you can see DC that is twice as long as BD, even though that in the drawing itself they are exactly almost equal to each other, but okay. So AD is the angle bisector. You can see that AD is the angle bisector because of the fact that it divides angle BAC into two halves. Each half equals to 60 degrees. So according to angle bisector theorem, we know that AD equals to X according to what is given as the question. According to rule number 3, we get that AD squared. This will be question number 3. AD squared equals to AB times AC minus BD times DC. Okay, so AD equals to x, so we substitute AD by x. So AD square is x squared, that is equal to AB here. AB equals to A and AC equals to 2A according to what is given as the question. So we substitute AB by A and we substitute AC by 2A minus BD. BD is 2, DC is 4. Minus 2 times 4 is minus 8. So in conclusion, we found out that x squared equals to A times 2A minus 8. Okay. So according to equation number 3, x squared equals to 2x squared, 2a squared minus 8. We have already found out that a squared equals to 36 over 7, so we substitute a squared in equation number 3 by 36 over 7. And we get that according to equation number 3, x squared equals to 2 times a squared is 36 over 7 minus 8. 2 times 36 is 72. So we write it down. So x squared equals to 72 over 7. Here we multiply minus 8 by 7 and then we divide it by 7 in order to have a common factor with this expression. Minus 8 times 7 is minus 56 over 7. 72 minus 56 is 16 over 7. So in conclusion, we actually found out that x squared, going to equation number 3, x squared equals to 16 over 7. We take out of this equation, equation number 3, and we get that x equals to square root of 16 is 4 over square root of 7. So here we actually found out that x equals to 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. Okay, so here we can write down here that x equals to either x that is equal to AD, it is equal to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. So we finished with the first method. In the next step I will present to you how to find out the length of side AD that is equal to x according to the second method. Okay? In the second method, we will define angle ADB as theta. BC is one side of triangle ABC, therefore it is absolutely a straight line. And we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on point D, on the upper side of the straight line BC, here the sum of the angles must be equal to 180 degrees. So if this angle equals to theta, this angle ADC must be equal to 180 degrees minus theta. In the next step, I will present to you a new law that is the law of sines. Okay, that is actually here. The law of sines. Here we have triangle ABC. That could be any triangle. We know that the length of side BC equals to A, the length of side AB equals to C, and the length of side AB equals to B. Then according to the law of sines, we get that A over sinus A equals to B over sinus B equals to C over sinus C. Here capital A, capital B, and capital C are the sizes of angles BAC, angle ABC, and angle BCA. Okay, capital A is the size of angle BAC. Capital B is the size of angle ABC. Capital C is the size of angle BCA, this angle. So we actually can implement the law of sines in our drawing. We implement the law of sines in this triangle ABD. This triangle ABD. According to the law of sines, we get that 2 over sinus 60 degrees equals to A over sinus theta. This will be equation number 1. In the next step, we'll implement the law of sines in triangle ADC. In triangle ADC, this will be equation number 2. Here 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. Okay, actually we have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. Sinus 180 degrees minus theta equals to sinus theta. According to this trigonometric identity, we can substitute sinus 180 degrees minus theta in this equation number 2, by sinus theta. So we'll do it now, and we get that according to equation number 2, 2A over sinus theta equals to DC over sinus DC over sinus 60 degrees here. According to equation number 1, A over sinus theta equals to 2 over sinus 60 degrees. That is to say, we can substitute A over sinus theta in this equation number 2, by 2 over sinus 60 degrees. We'll do it now, and we get that according to equation number 2, according to equation number 2 times A over sinus theta, according to equation number 1, is 2 over sinus 60 degrees. And it is equal to DC over sinus 60 degrees. Here, this equation number 2, we have sinus 60 degrees on both sides of equation number 2. So sinus 60 degrees will get cancelled. What is left from equation number 2 after we cancel sinus 60 degrees? In this side we have 2 times 2. On the other side of equation number 2 we have DC. So DC equals to 2 times 2. That is to say DC equals to 4. So DC equals to 4 units. So here we found out that DC equals to 4 units, exactly as we already found out in the first method. Okay? In the next step, I will present to you shortly the law of cosines, and we will implement the law of cosines in this triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. Here, the length of side BC is equal to C units. The length of side AB equals to A units. And the length of side AC equals to B units. Then according to the law of cosines, we will get that cosine theta equals to A square plus B square minus C square over 2 times A times B. So in any triangle, cosine theta equals to A square plus B square minus C square over 2 times AB. So we actually implement all the law of cosines in triangle ABC. Okay, so I'll copy triangle ABC in a new page and we'll implement the law of cosines in triangle ABC. Side BC equals to 2 plus 4 is 6. BC equals to 6 units. AB equals to A. AC equals to 2A according to what is given as the question. angle BAC, this angle equals to 60 degrees plus 60 degrees, that is 120 degrees. So this is triangle ABC that they copied from the original drawing. We'll implement the law of cosines in this triangle ABC. According to the law of cosines, we will get that cosine 120 degrees equals to a squared plus b squared. A squared is ab squared and ab equals to a, so it is a squared plus b squared. B squared is ac squared, and ac equals to 2a, so it is actually 2a squared, and 2a squared is 4a squared minus c squared. bc equals to c, so and bc equals to 6, so bc squared is 6 squared, that is 36 over 2 times a times b, so it is over 2 times a is ab, that is a, and b is ac, that is 2a. Okay, so here cosine 120 degrees equals to minus 1/2, and this is equal to 4a squared plus a squared is 5a squared minus 36 over 2a times 2a. Here we have 2 on both sides of the equation, so 2 will get cancelled, and we will multiply this equation by 2a squared, and we get that minus 1 times 2a squared is minus 2a squared, that is equal to 5a squared minus 36. So this will be question number 3. We will add to equation number 3 2a squared, and we will also add to it 36 simultaneously, and we will get that 5a squared plus 2a squared is 7a squared, that is equal to 36. Here we divide this equation number 3 by 7. And we get that according to equation number 3, a squared equals to 36 over 7. Here we take a root out of this equation number 3, and we get that according to equation number 3, a equals to the square root of 36, that is 6 over 7. This is actually a equals to 6 over square root of 7. In the next step, I will present to you a new formula to calculate the area of any triangle. So according to the new formula, if we have a triangle ABC, that could be any triangle. This is triangle ABC. This is angle theta. The length from side AB is equal to A units. The length of side AC equals to B units. So according to the new formula, the area of this triangle ABC, is equal to A times B times sinus theta over 2. We'll implement the new formula. We'll use it in our drawing. In our drawing, we know that the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. Okay, I'll write it down. The area of the big triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. Okay. In the next step, we'll use the new formula that I presented to you here in order to find out the area of all the three triangles. So the area of triangle ABC according to the new formula will be equal to A times 2A times sinus 60 degrees plus 60 degrees is 120 degrees over 2. This is the area of triangle ABC. It is equal to the area of triangle ABD. We use the new formula in order to find out the area of triangle ABD. The area of triangle ABD according to the new formula will be equal to A times X times sinus 60 degrees over 2 plus the area of triangle ADC. According to the new formula, we'll get that the area of triangle ADC equals to X times 2A times sinus 60 degrees over 2. Okay, we used the new formula that I presented to you in order to find out the area of triangles ABC, ABD, and ADC. So here we have 2 in the denominator of both sides of this equation, so 2 will get cancelled. We know that sinus 120 degrees equals to sinus 60 degrees. So we can cancel also sinus 60 degrees. And we have A on both sides of the equation, so A will also get cancelled. And what is left of this equation after we cancelled all the variables here? What is left here that in this side we left with here 2A it is A times 2A. It is A times 2A. Okay, it is A times 2A times sinus 130 degrees over 2. So in this side of the equation we left only with 2A. In the other side of the equation we have here x plus 2x. So according to the equation, this equation 2A equals to x plus 2x. So here 2a equals to x plus 2x is 3x. Here we divide this equation by 3 and we get that x equals to 2 over 3 times a we already found out that a equals to 6 over square root of 7 units. We substitute a by 6 over square root of 7 units. Here 6 over 3 is 2. So it is 2 times 2 over square root of 7 units. 2 times 2 is 4. So in conclusion we found out that x equals to either 4 over square root of 7 units, or in terms of numbers it is equal to 1.5 units. We finish with the second method. In the next step we'll summarize the lecture. We'll start with the first question. Here, in the first question, we have square ABCD. Inside the square we have this circle, and the radius of this circle is equal to 2 units. And line segment DE equals to 1 unit. And we want to find out the length of the side length of square ABCD. We define the center of this circle as point O. Then from point O we join points O and M together by a straight line. O is the center of the circle and M is the point of the circle itself. So OM is the radius of the circle. This is exactly the definition of a radius. Okay? Therefore OM is the radius of this circle, so we define the radius of this circle as R, and R equals to 2 units according to what is given as the question. So here we have the radius OM that is drawn to the point of tendency. That is to say the radius OM which is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent DA will be perpendicular to the radius MO. So DA is perpendicular to MO. That is to say this angle equals 90 degrees and this angle will be also equal to 90 degrees. Likewise, we connected the points O and L together by a straight line. OL is the radius of the circle for the same reasons. So we have here the radius OL that is drawn to the point of tendency. That is to say the radius OL it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius AO. So AB is perpendicular to LO. That is to say this angle equals 90 degrees and this angle will also equal to 90 degrees. Okay? And we also note that all the angles inside the square are right angles. Therefore, angle DAB equals to 90 degrees. So in quadrilateral MOAL, we have 1, 2, 3 right angles. And the sum of 3 right angles is equal to 90 times 3, that is 270 degrees, plus the size of the fourth angle, that is actually angle MOL. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in a quadrilateral is equal to 360 degrees. Okay, here we subtracted 270 degrees from this equation and we found out that the missing angle MOL equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So here, this angle is a right angle, therefore quadrilateral MOAL, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, so we relate to quadrilateral MOAL as a rectangle. Okay, and we also know that the opposite sides of a rectangle are equal to each other. So the opposite sides of a rectangle MOAL, they are equal to each other, that is to say MO equals to AL. MO equals to AL, but we have already found out that MO equals to 2 units. This is the radius of the circle. MO equals to 2 units, so from this equation 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. Here, AL equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MA equals to LO. MA equals to LO, but LO equals to 2 units. This is the radius of the circle, so we can write here that LO equals to 2 units. And from this equation, MA equals to LO equals to 2, we derive that MA also equals to 2. Here, MA is also equals to 2 units. Actually, we found out that all the sides of quadrilateral MOAL they are equal to each other, therefore quadrilateral MOAL is not a rectangle but a square. Quadrilateral MOAL is a square. Then I presented to you rule number 2. According to rule number 2, the lengths of 2 tangents from a common external point to a circle are equal. So if you focus on the common external point, point E, from point E we have 2 tangents to this circle, tangent EM and tangent EZ. According to rule number 2, they must be equal to each other. So EM equals to EZ according to rule number 2. What is the length of EM? Here EM, from the drawing, it is very easy to see that EM equals to DA minus DE minus MA. EM equals to DA minus DE minus MA. And we actually defined the side length of the square ABCD as X. So DA equals to DC equals to CB equals to AB equals to X. So EM, it is actually equals to A, that it is X according to our definition, minus DE, that is 1 according to what is given as the question, and MA is 2 according to what we have already found out. And so in conclusion, we found out that EM equals to X minus 1 minus 2, X minus 1 minus 2 is X minus 3. So here, EM equals to X minus 3. But according to rule number 2, we have already found out that EM equals to EZ from one side, and from the other side, we just right now found out that EM equals to X minus 3. So here, from this equation, X minus 3 equals to EM equals to EZ, we derive that EZ is also equals to X minus 3. Here, EZ equals to X minus 3. Then we focused on the common external point, point B. From the common external point, point B, we have 2 tangents to this circle, tangent BL and tangent BZ, and according to rule number 2, they must be equal to each other. Repeat again, BL must be equal to BZ according to rule number 2. Okay, what is the length of BL? The length of BL, from the drawings is very easy to see that BL equals to AB minus AL. Okay, BL equals to AB minus AL. AB equals to X according to our definition, and we already found out that AL equals to 2. So in conclusion, BL equals to X minus 2. So actually, According to rule number 2, we found out that BL equals to BZ. And we just right now found out that BL also equals to x minus 2. So from this equation, x minus 2 equals to BL equals to BZ, we derive that BZ is also equals to x minus 2. Here, BZ is also equals to x minus 2. Okay? Then we found out that length of line segment EA. From the moment it's very easy to see that EA equals to DA minus DE. Again, DA minus DE equals to EA. Here, AE or EA, it is the same. It is DA minus DE. DA equals to X according to our definition, and DE equals to 1 unit according to what is given as the question. So in conclusion, we found out that EA equals to X minus 1. EA equals to X minus 1. So I copied the right triangle EAB in a new page and we implemented the Pythagoras theorem on this right triangle, triangle EAB. This is the right triangle EAB that I copied from the original drawing. We have already found out that side EA equals to X minus 1 and AB equals to X, and the hypotenuse EB equals to X minus 3 plus X minus 2. So the hypotenuse EB equals to X minus 3 plus X minus 2. That is to say, X plus X is 2X and minus 3 plus minus 2 is minus 5. So in conclusion, we found out that the hypotenuse EB equals to 2X minus 5. Okay, now we can implement the Pythagoras theorem on this right triangle, triangle EAB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. The hypotenuse is AB, so the square of the hypotenuse is EB square, and it is equal to EA square plus AB square. EB equals to 2X minus 5, EA equals to X minus 1, and AB equals to X. So we got that 2X minus 5 square equals to X minus 1 square plus X square according to equation number 1. We open the brackets on both sides of equation number 1. According to the geometric identity that A plus A minus B square equals to A square plus B square minus 2 times AB. So here we get actually the 2x minus 5 squared equals to 2x squared, that is 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times AB. Minus 2 times 2x is minus 4x, and minus 4x times 5 is minus 20x. That is equal to x minus 1 squared. X minus 1 squared equals to x squared, plus 1 minus 2x, plus x squared. Here we subtracted x squared plus x squared is 2x squared. So in this side of the equation we have 2x squared minus 2x plus 1. In the other side of the equation we have 4x squared minus 20x plus 25. Here we subtracted 2x squared from this equation, equation number 1. 4x squared minus 2x squared is 2x squared. Here 2x squared minus 2x squared is 0. We subtracted, we added 2x to this equation, equation number 1. So minus 20x plus 2x is minus 18x, and 2x minus 2x is 0. We added 1 to this equation, equation number 1. We subtracted 1 from equation number 1. So 25 minus 1 is 24, and 1 minus 1 is 0. So in conclusion, we found out that 2x squared minus 18x plus 24 equals to 0. Here we divided this equation, equation number 1 by 2, and we got that 2x squared over 2 is x squared, minus 18x over 2 is minus 9x, and 24 over 2 is 18. So in conclusion, we found out that x squared minus 9 squared plus 12 equals to 0. Here the coefficient A equals to 1, the coefficient B equals to minus 9, and the coefficient C equals to 12. And the general formula for solving out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So here x equals to minus b, b equals to minus 9, so minus b is minus 9, this is plus 9, plus minus b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81. minus 4 times A is 1, that is times C is 12. Okay, so here we got that x equals to minus 9 plus minus square root of 81, and minus 4 times 12 is minus 48 over 2. So here we got that x equals to 9 plus minus 81. 81 minus 48 is 33. So inside the root you left only with 33. So here we have two solutions of possible for x. X equals to 9 plus minus square root of 33 over 2. The first solution for x is that x equals to 9 minus square root of 33 over 2. And 9 minus square root of 33 over 2 is 1.62. But here, from the drawing, you can see that AB is equal to x. Here AB equals to x. That is to say, x is greater than AL. X is greater than AL, and AL equals to 2. So if x is greater than AL and AL equals to 2, it means that x equals to 2. X is greater than 2. Okay? X must be greater than, x is greater than AL and AL equals to 2, so x is greater than 2. X must be greater than 2, and 1.62 is less than 2, and x must be greater than 2, so this solution is an incorrect solution. We left only with the second solution, that x equals to 9 plus square root of 33 over 2. 9 plus square root of 34 over 2 is about 7.37 units. Okay, so we finished with the first question. In the next step, I present to you the two solutions for the second question. We start with the first method. So here we have triangle ABC. We know that side BD, line segment BD equals to 2 units, and AB equals to A, AC equals to 2A, angle BAD equals to 60 degrees, and angle CAD equals to 60 degrees, and we want to find out the length of side AD that is equal to x. So first of all, I presented to you the angle bisector theorem. The angle bisector theorem is true in any triangle. So if you have this triangle, triangle ABC, that could be any triangle, and you have AD is the angle bisector. Why? Because it divides angle BC into two halves. Each half equals to theta. So because we have the angle bisector AD, you can implement the angle bisector here. So according to the angle bisector theorem, we get that AB over AC equals to BC over DC again. AB over AC equals to BD over DC. Okay, so we can implement the angle bisector theorem in triangle ABC. Why? Because in triangle ABC we have AD, that is the angle bisector. Okay, so in triangle ABC we get that according to the angle bisector theorem, AB over AC equals to BD over DC. AB over AC equals to BD over DC. Here AB equals to A units and AC equals to 2A units. BD equals to 2 units and DC is the missing line segment. So here A over A is 1, so A will get cancelled, and this side of the equation we left only with 1 half, that is equal to 2 over DC. here because multiplied this equation and found out that DC equals to 2 times 2, that is 4. Okay, DC equals to 4 units. This equals to 4 units. Okay, then we made the construction. We extended side CA of triangle ABC by a straight line, and then from point B we raised perpendicular to the extended CA. So this angle equals to 90 degrees according to our construction. Okay, repeat again, angle AEB equals to 90 degrees according to our construction. So actually, line segment CE was created by the extension of the straight line CA by a straight line. And when you extend a straight line by a straight line, the result must be a straight line. So here, therefore CE is a straight line. So if we focus on the lower side of the straight line EC at point A, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the lower side of the straight line EC at point A? We have 60 degrees plus 60 degrees plus angle EAB. Here 60 degrees plus 60 degrees plus angle EAB according to the rule that I mentioned, it must be equal to 180 degrees. 60 degrees plus 60 degrees is 120 degrees, so 120 degrees plus angle EAB must be equal to 180 degrees. We subtracted 120 degrees from this equation and found out that angle EAB equals to 60 degrees. Okay, this angle EAB equals to 60 degrees. Then we focus on the green eye triangle, triangle EAB. On the green eye triangle, triangle EAB, cosine 60 degrees equals to EA over EB. Cosine 60 degrees equals to EA over EB. So it is equal to EA over AB. AB equals to A according to what is given as the question. So we substitute EA by A. And cosine 60 degrees equals to 1 half, so we substitute cosine 60 degrees by 1 half. So 1 half equals to EA over A. We multiplied the equation by A and we found out that EA equals to A over 2. EA equals to A over 2. Then we have we will continue to focus on the right green triangle here. Sinus 60 degrees equals to BE over AB. Sinus 60 degrees equals to EB over BA. So it is EB over BA, but BA equals to A, so we substitute BA by A, and we found out that sinus 60 degrees is equal to 3 over 2, so in conclusion we found out that square root of 3 over 2 equals to BE over A. We multiplied this equation by A and we found out that EB equals to A times square root of 3 over 2. Here BE equals to A times square root of 3 over 2. Then we implemented the Pythagoras theorem on the right triangle, on the right base triangle, triangle BEC. According to the triangle BEC, on this page, we implemented the Pythagoras theorem on this right triangle, triangle BEC. Here, EC equals to 2A plus A over 2, that is 5 over 2A. BE equals to square root of 3 over 2 times A. And BC, the hypotenuse BC equals to 2 plus 4, that is 6. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BC square equals to EB square plus EC square. BC equals to 6, so BC square is 6 squared, that's 36, plus EB square. EB equals to square root of 3 over 2 times A, so EB square is square root of 3 over 2 times a squared, and it is equal actually to 3/4 times a squared plus EC squared. EC equals to 5/2 times a, so EC squared is 5/2 times a squared, and 5/2 times a squared equals to 25/4 times a squared. Here we have 3/4 plus 25/4 is 28/4, and 28/4 is 7, so if we found that 30x equals to 7a squared, we divided this equation by 7 and found out that a squared equals to 36/7. Okay, according to equation number 2, we took out all of this equation number 2, and found out that a equals to 6 over square root of 7 units. Okay, then I presented to you rule number 3. According to rule number 3, if we have a triangle ABC, that could be any triangle, and AD is the angle bisector, then according to rule number 3, AD squared equals to AB times AC minus BD times DC. We implemented rule number 3 in triangle ABC, so I copy triangle ABC in this page, and here, according to rule number 3, we get that AD squared equals to AB times AC minus BD times DC. Okay, AD equals to x, so AD squared is x squared, AB equals to A, and AC equals to 2A. Okay, so here we have x squared, and 8 times 2a is 2a squared minus 8. Okay, so here we have x squared that is equal to 2a squared minus 8, and we found out that a squared equals to 36/7, so we can substitute a squared by 36/7. Here we did it, and we got that x squared equals to 2 times 36/7 minus 8. 2 times 46 is 72, so multiplied 8 by minus 8 by 7, and then we divided by 7 in order to become factor with this expression. 72 minus 56 is 16, so it is 16/7. Okay, so we found out that x squared equals to 16/7, and here x squared equals to 16/7. We took out all of this equation and found out that x equals to square root of 16 is 4 over square root of 7. So x equals to 4 over square root of 7, and in terms of numbers it is equal to 1.51 units. Okay, once I'm done for square ABCD equals to 1.51 units. So we finish with the first method, then I presented to you how to find out actually here I meant to say that here AD that is equal to x, it is equal to 1.51 units, okay? Then I presented to you the second method to find out the length of line segment AD that is equal to x. Here we define this angle as theta, therefore this angle must be equal to 180 degrees minus theta. Then I presented to you the law of sines. The law of sines is true in any triangle, so if we have this triangle ABC, that would be any triangle. Side AC equals to 3 units, side AB equals to B units, and side BC equals to A units. Capital A is the size of this angle, capital B is the size of angle ABC, capital C is the size of angle ACB. Then according to the law of sines, we get that A over sine A equals to B over sine B equals to C over sine C. We implemented the law of sines in triangle ABD. So in triangle ABD, this triangle, according to the law of sines, we get that 2 over sine of 60 degrees equals to A over sinus theta. Then we implemented the law of sines in this triangle ABC. According to the law of sines, we get that 2a over sinus 180 degrees minus theta equals to dc over sinus equals to dc over sinus 60 degrees. Okay. We have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta, so we can substitute sinus 180 degrees minus theta by sinus theta in this equation, equation number 2. We did it, and we got that according to equation number 2, 2 times sinus theta equals to dc over sinus 60 degrees. Here we have a over sinus theta in equation number 2, but a over sinus theta according to equation number 2 equals to a to 2 over sinus 60 degrees, so we can substitute a over sinus theta in equation number 2 by 2 over sinus 60 degrees. We did it, and we got that according to equation number 2, here we have 2 times a over sinus theta is 2 times sinus 60 degrees, that is equal to dc over sinus 60 degrees. We have sinus 60 degrees in both equations, in both sides of equation number 2, so sinus 60 degrees will get cancelled. And we have to live with 2 times 2, that is equal to dc. That is to say, dc equals to 2 times 2, that is 4. Then I presented to you the law of cosines, and we implemented the law of cosines in our triangle ABC. According to the law of cosines, if you have triangle ABC that could be any triangle, the length of side AB is A units, the length of side AC is B units, and the length of side BC is C units. Then, according to the law of cosines, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. We actually implemented the law of cosines in this triangle ABC. We copied triangle ABC from the original drawing. This is triangle ABC, and according to the law of cosines, we get that cosine 120 degrees, it is equal to A squared plus 2A squared minus 6 squared over 2 times A times 2A. Okay, cosine 120 degrees equals to A squared plus 2A squared, that is 4A squared, minus 6 squared, that is 36 over 2 times A times 2A. Cosine 120 degrees equals to minus 1 half. And here 4A squared plus A squared is 5A squared, minus 46 over 2A times 2A. Here we have 2 on both sides of the equation, so 2 will get cancelled. And then we multiply the equation number 3 by 2A squared. 2A squared minus 1 is minus 2A squared, that is equal to 5A squared minus 46. We added 2A squared and added also 36 simultaneously to this equation, equation number 3, and we found out that 5A squared plus 2A squared is 7A squared, that is equal to 36. We divided this equation, equation number 3 by 7, and found out that A squared equals to 36 over 7. Then we took out all of this equation, equation number 3, and found out that A equals to square root of 36 is 7 over square root of 7. So in conclusion, A equals to 6 over square root of 7 according to equation number 3. Then I presented to you a new rule to find out the area of any triangle. So if we have this triangle ABC that could be any triangle, the angle between side AB and side AC is theta, the length of side AB is A, and the length of side AC is B. Then the area of this triangle ABC equals to A times B times sinus theta over 2. We use this formula in order to find out the areas of these triangles. According from the drawing, it is very easy to see that the area of the big triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. Okay, so the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. The area of triangle ABC according to the new formula, the area of triangle ABC will be equal to A times 2A times sinus 120 degrees over 2. A times 2A times sinus 120 degrees over 2. And this is equal to the area of triangle ADC, that is A times X times sinus 60 degrees over 2. Here. A times X times sinus 60 degrees over 2 plus the area of triangle ADC, that is equals to 2A times X times sinus 60 degrees over 2. Okay, here X times 2A times sinus 60 degrees over 2. We have 2 on both sides of the equation, so 2 will get cancelled. Sinus 120 degrees equals to sinus 60 degrees, so sinus 60 degrees will also get cancelled. And we have A on both sides of the equation, so A will also get cancelled. What is left after we cancelled all the variables in this equation? What is left from this equation is 2A equals to X plus 2X. X plus 2X is 3X, so 2A equals to 3X. We divided this equation by 3 and we found out that X equals to 2/3 A. X equals to 2/3 A. We have already found out that A equals to 6 over square root of 7 units, so we substitute A here by 6 over 7 square root of 3 units, and found out that X equals to 2 times 6 over 3 times square root of 7 units. 6 over 3 is 2, so here we will have 2 times 2 over square root of 7 units. 2 times 2 is 4, so in conclusion we found out that X equals to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.5 units. Okay, thank you very much.